Okay, let's go back and do 13 again. I think I'm going to go all the way back to the beginning. So I'm going to get rid of this. Let's go all the way back and just talk through this again. There's a really fast way to work this problem, but if you haven't been taught the fast way, it's not going to make, if I do tell it to you now, it may not make that much sense to you. So let's do this instead. Okay, if the input value is 1 into the g function, that means if whatever I put inside is equal to a 1, then the output has to be 0. Okay, so when we are told that g of x minus 2 is what we're going to evaluate, if that's going to equal 0, then this expression has to be equal to a 1. So this means that x is equal to 3. So this is the point 3 comma 0. The input is the x, the output is the y. So our answer choice has to contain the point 3 comma 0. A does not. What did I say? 3 comma 0. B does. C, graph C does not. Graph D does not. And graph E does not. So answer choice B has to be the correct answer. Now the easy way to do this problem is to just know about translations. Anytime you have a graph of g, no matter what it looks like, if you look at the graph of g of x minus 2, that just means slide the graph 2 spaces to the right and redraw the graph. That's all that means. Now be careful. If the minus 2 is on the outside of the parentheses like this, that means something totally different. That means slide the graph down 2. So you can see that if you know your rules for translating graphs, left, right, up, and down, that can make these problems go by a lot faster. So if we move the graph 2 spaces to the right, it looks like this one, which is exactly the same graph as B. 14. After 6 new cars enter the parking lot and 2 cars leave the parking lot, there are 2 times as many cars as before. How many cars were parked in the parking lot before the changes? Okay, so let's let x be the original number of cars. So after 6 new cars enter the parking lot and 2 cars left the parking lot, this result is twice the number of cars before. So that means x plus 4 is equal to 2x. So we subtract x from both sides. So there were 4 cars in the parking lot. B. If you don't like the algebra, which you may not, just do some guessing and checking with the answer choices and see which one makes sense. Let's look at number 15. 4 students reach into a bag of coins. Those 4 students are Steve, Joe, Kyle, and Ryan. Steve grabs 1/3 of the coins. Joe grabs 1/4 of the coins. And Kyle grabs 1/6 of the coins. If Ryan gets the remaining 6 coins, notice they don't tell us a fraction, they give us a number of coins. How many coins were originally in the bag? Well, Steve took 1/3 of the original. Let's let x be the number of coins originally. Now this means, what? Plus Ryan takes 6 coins. How many coins were originally in the bag? Ryan gets the remaining 6 coins.